everyone, my name is Lorraine PALACIOS and I'm with my groupmate,
Eirick.
We are from BSIT 2C. Today, we are presenting our system called Simple Banking System, also branded as Woah.
Our system is designed to help users manage their bank accounts digitally. Users can create accounts, log in, deposit, withdraw, transfer funds, and view transaction history. The intended users are bank customers who want a simple and secure way to manage their accounts using a desktop application.
So, we built our system using Java, specifically in Netbeans, because Java provides robust support for GUI development through Swing. And for the database, we used MySQL with MySQL Workbench to design and manage our database. To connect Java to MySQL, we used the JDBC Java Database Connectivity. These tools were chosen because Java Swing allows us to create modern and responsive interfaces. MySQL is reliable for storing account and transaction data, and JDBC provides a standard way to interact with the database directly from Java.
Our database is called BankDB. It has two main tables called account and transactions. The accounts table contains the account number, name, PIN, and balance. The transaction table contains the ID, account number, type, amount, balance, and date.
And these tables are related through the account number, which allows us to track transactions for each account efficiently. So, in creating an account, we can create a new account by clicking Sign Up on the login screen. We enter first name, surname, date of birth, account number, and PIN. And behind the scenes, the system calls account controller.create account, which uses account DAO.insert account to store the record in the accounts table. And second is, after logging in, the user sees the dashboard with their account info and current balance. The recent transactions are displayed using transaction DAO.getTransactions, which queries the transactions table and populates the table in dashboard form. So, in clicking deposit or withdraw, opens a prompt. The system updates the account balance in the database via account DAO.updateBalance. And each transaction is also logged in the transactions table using transaction DAO.insert transaction.
Throughout the demo, the UI elements like buttons, input fields, and tables are all connected to the controller, which ensures the action updates both the database and the display correctly. Code walkthrough. We'll start with the foundation of our system, the database connection class. The FileDB connection is responsible for connecting our Java program to our MySQL database. Inside this class, we use the JDBC API. We prepare our database, URL, username, and password, and then we call driver manager.connection. This class returns a connection object, which is then reused by all the other classes, such as the DAOs.
Model layer. Account model. The account.java class represents a single bank account. Instead of manually handling account data, we store them inside an account object. It contains account number, full name, date of birth, current balance, and PIN.
Next is transaction.java. which represents a single transaction entry. A transaction record contains the transaction ID, account number, type the deposit, withdraw, or transfer, amount, balance after the transaction, and date and time. Every time the user performs any action involving money, the system automatically creates a new transaction object and passes it to the DAO to be saved in the database.
The DAO layer. This is the biggest backend layer. The account DAO.java that handles all account-related SQL. Account DAO is the backend class responsible for talking directly to MySQL. It contains all SQL queries for creating a new account, verifying login, updating balance, checking if an account exists, fetching account details. We use prepared statement to prevent SQL injection and to safely pass user inputs. When the user logs in, account DAO fetches the machine account row, converts it into an account object, and returns it to the controller.
Next is the transaction DAO. Transaction DAO stores and retrieves transaction records. It contains two main functions. The first one, insert transactions. This runs an SQL insert that saves the new deposit, withdrawal, or transfer. The second one is get transactions by account. This method retrieves all previous transactions of a specific account. This is used to display the transaction table in the dashboard UI.
The controller layer. This is the heart of the system. All logic goes here. The account controller.java files handles all business logic and connects to the GUI to the database. It acts as the middleman between GUI to the controller, to the DAO, and to the database. It contains the logic for logging in, creating an account, deposit, withdraw, and transfer. The GUI layer. These are the screens the user interacts with. Login form.java. This is the screen where the user enters their account number and PIN. When the user clicks login, the form sends the input to controller.login. If login is successful, the dashboard opens. If not, a message dialog shows an error.
Next is the register form. The registration form collects the first name, surname, date of birth, account number, and PIN. After clicking create account, form sends all data to controller.createAccount. Then, the controller validates it and inserts the new account through the DAO. Next, a confirmation dialog appears.
The dashboard form.java. This is the main user interface after logging in. It shows the user's name, account number, current balance, recent transactions table. Buttons available are deposit, withdraw, transfer, transaction history, and logout. Each button triggers controller methods like controller.deposit, the account or amount, controller.withdraw, also the account and amount.
Transaction history form.java. This form shows all past transactions. It calls transactions DAO, .get transactions by account, and displays the results in a JTable.
The utility layer. We created a reusable class for showing pop-up messages. It simplifies showing success alerts, errors, and confirmation messages.
And lastly, the system flow. To summarize the entire code structure, users log in, goes through the login form, controller, account DAO, then finally the database. The dashboard loads to the controller, fetches balance plus transactions. When a user deposits, it goes through the controller, the account DAO, the transaction DAO, then it finally updates the UI. Same goes when a user performs a withdrawal. If a user performs a transfer, it both updates the sender and the receiver's database.
Okay, so next naman, i-explain naman namin yung system flow na ginawa naming system. Okay, so first, login screen natin. So kapag yung user natin nag-input siya ng credentials dito and nag-match sa existing data sa ating database, automatically mag-open yung yung dashboard ng system natin. Pero kapag invalid naman, magdi-display lang siya ng error message. So kapag nakapag-login na yung user natin, makikita niya yung dashboard natin, automatically mag-open yan. So naka-display dito yung username nila, and account number, balance, transaction history, tsaka yung buttons natin na deposit, withdraw, transfer, and logout. So lahat ng data dito na nakalagay is ina-handle lahat ng ng database natin sa MySQL. So yung withdrawal function naman natin, i-deduct lang yung amount na gusto nyong i-withdraw. Tapos, i-update niya sa transaction history natin ulit. so yung transaction history naman natin, yung nag-handle dito is yung transaction DAO natin. Lahat ng deposits or withdrawal, nakastore siya sa database natin. Tapos, yung table rin natin, nakastore rin yun sa database para lahat ng user, nasa-save yung mga transaction history nila.
So, during the development of our banking system, we faced several important challenges that strengthened our understanding of software development. And one of the first issues we encountered involved connecting Java to MySQL, where we ran into multiple JDBC related errors such as incorrect URLs, authentication failures, and driver loading problems. So these errors made it difficult for our system to access the database. So we had to carefully review our connection string, verify our MySQL username and password, and ensure that the MySQL service was running properly. And another major challenge was handling money transfers in an atomic way. And since a transfer requires decreasing the balance of one account and increasing the balance of another, we had to ensure that both updates happened successfully, or otherwise the database could end up with incorrect or incomplete financial records. And designing this logic taught us the importance of consistent data handling and how to avoid partial transactions. Input validation for deposits and withdrawals also became a challenge because users can enter invalid data such as negative numbers, letters, or amounts larger than their actual balance. And to solve this, we added strict validation rules that only allow positive numbers and require accounts to have sufficient funds before any withdrawal or transfer is processed.
Through these challenges, we learned several valuable lessons. We gained a deeper understanding of the multi-view controller architecture, which helped us organize our code by separating the data layer, user interface, and system logic. This structure made our project easier to maintain and debug. We also improved our knowledge of JDBC by learning how Java communicates with MySQL database, how queries work, how to manage connections, and how to handle SQL exceptions properly. Finally, we strengthened our GUI development skills using Java Swing, learning how to design interactive forms, handle events, and create user-friendly screens, such as the login form, register form, dashboard, and transaction history viewer. Overall, these challenges and experiences allowed us to develop better problem-solving skills, write cleaner and more structured code, and understand how real-world systems manage data and user interactions. So our simple banking system allows users to register, manage accounts, perform transactions, and track transactions history in a simple and secure way. To close our presentation, our simple banking system successfully showed how Java, MySQL, and JDBC can work together to create a functional application. Our system allows account registration, login, deposits, withdrawals, transfers, and viewing transaction history, all saved securely in the database.
And throughout the project, we faced challenges such as connection errors, logic bugs, and UI adjustments, but we were able to fix them through teamwork and research. We also learned a lot about Java GUI design, database handling, and organizing code using the MVC structure. And once again, I'm Lorraine PALACIOS and
I'm Eirick
from BSIT 2C, and this concludes our presentation. Thank you for listening.